In this clip, I want to go through the meshing of the SVEs. So you will see the end result here. And now I also briefly want to just mention this software. It's called ParaView. So you will need this when you mesh and when you then later want to see the mesh. So ParaView is a free software. So what you do is that you go to paraview.org and then go to the download section. And yeah, then you click whichever version you want. So probably you want this one, the executable file for Windows. And then you install it, and then you are ready to go. So this is what the meshed SVE will look like, and we will mesh it right now. So if we go back to MATLAB, here is the SVE that we have now. We generated this previously by invoking this method generate SVE. So what we will do now is that we will mesh it. So then we just invoke this meshing method. So the only object property of these properties that you want to set now is this value here. So now we set nx to 80. Nx is the number of elements along each length. So if we zoom in, this is has a very high resolution. So the number of cubes or voxels in each direction is nx. So you will have in total the value of nx to the power of 3 number of elements. So nx to the power of 3, that's the amount of elements that you will have. And this could be any value really. So we set this to 80 for now, and then we'll see what it looks like. So you basically just set a value here, and then you call this method meshSVE. So let's run and see what happens. So then it tells you that it's meshing, and now I will pause the video until it's finished. So now the meshing is done, and it will also display the total meshing time, which was 7 minutes for this value of nx. And if we go into the file or the folder, sorry, where we have previously had the SV parameters, now we have created this file, which is a topology bundle, and this contains all the matrices required for any type of calculation. So we had a lot of topology matrices of various sorts. So it stores all of information related to nodes and elements and coordinates and boundary elements and boundary nodes and so on and so forth. And this has the, so this here we have underscore 80, which obviously refers to the value of nx, and then underscore 1, which is the same one as here, which is realization 1. So now we have all the meshing done, and to visualize the mesh, we invoke this method called write topology. So we can easily do that in this way. So now we call this method to be able to visualize what the model actually looks like. So we run the model now. And now it says similarly that it writes topology to file. And I think this method is somewhat faster than the previous one, so I don't have to pause the video. So now, so now it was already done, as you see here. And now we have a new file, topology, and then the underscore with these two values. And this is the file that you read into ParaView. So if we double click this one, we open another instance of ParaView, and then you click apply here, and then it reads in this file. So the file extension is VTK, which is a file format. So yeah, I should say this also or mention this. This is basically just a text file. So you can open it using any text editor. And this is the structure of the file. So this here are the XYZ coordinates of each node. And then here is some element topology. So these connects the different nodes to make one element, one cube, that is. So this is just a text file, and it needs a specific structure, which is generated by MATLAB. And but when you open the text file in ParaView, you can see the model being rendered. Okay, so this is what the model looks like now. What you can do in this software is to use this filter threshold. So you also find this here. If you go to threshold and alphabetical, there is a bunch of filters here, obviously. But if you go to there it is, threshold. So if you click threshold, then you can filter out different parts of the model. So material is a property here, and material. So this model has three values for the different materials. So 0 is for cement, and I think it is 2 is the aggregates, and the value 1 is the ITZ layer. So by filtering out all the zeros, we filter out all the cement. So if we apply this filter and then apply it like this, then now you see only the aggregates with the ITZ around it. Now you see here that this is a very crude mesh because we had the value was 80 compared to this one, where here it's 300, so it has a much higher resolution. So this is relevant for your ultimately the computational result that you get in the end. So you need to have a sufficiently dense mesh. So this is obviously not dense enough. Okay, so but now we have filtered out the cement, and if we increase this above 1, so now we also filter out the the ITZ. So now only the value 2 is left, which corresponds to the aggregates. So if we apply this, no, sorry, it was the other way around. So if 2 is ITZ, so 1 is gravel. So if we filter like this, so now we're only keeping the ones. Now we only see the actual aggregates. And as you see, this should follow the sieve curve that we've used as input. And yeah, so if we now go back to the model, if you mesh and then you invoke this method write topology and you realize that the mesh is too crude, what you basically just have to do is that you just invoke this method again, and you type in a different number. So now if we type 100, or we can do this in one sequence. So you can invoke this method and then directly after, you can invoke this method directly after. So once it has finished meshing, it will directly start to write the topology file. So if we do this for 100, we can see the difference. So now we run, and now I pause the video until it's finished. Okay, so now the meshing is done. It took 14 minutes, and it's also written the topology to a file. So now if we go into the folder here, we now have this. First of all, we have the topology file, which is a MATLAB file, and then this ParaView file. So if you open this one, it will have a higher resolution than the 80. So this is what the 80 nx equal to 80 file look like. This is the resolution for this one. And then I will pause. Yeah, so now the file is loaded. So this is now the topology file for a resolution of 100. So if we apply the same filter here, you see that this is somewhat higher resolution than the other one, which looked like this, 80. So this is obviously useful when you want to do some sort of convergence analysis. So because you want to make sure that you have a sufficiently high mesh, and you can just increase the mesh by changing this value of nx, and then we'll just generate new meshes, and you can just invoke these two methods to create the new meshes. So again, this mesh SVE creates this type of file, this MATLAB file, and then the write topology method creates the file used for visualization in ParaView.